You may start now.
Oh, good evening, everyone. It is my pleasure to welcome you all to day 5 of the AIKN series under the ongoing event Artificial Intelligence Knowledge Sharing. Today we are truly honored to have our respected dignitaries among us, Dr. Sandeep Negi sir, Professor Amit Verma sir, and our esteemed guest of the day, Mr. Rajat Thaplia sir. A very warm welcome to all of you. Now, I would like to hand over the mic to Sandeep Negi sir for honoring the guest. Now, I would like to introduce our guest of the day, Mr. Rajat Thapliyal sir. Mr. Rajat Thapliyal sir belongs to Dehradun, Uttarakhand. He has completed his BTech in Electrical and Electronics Engineering in 2013 and his MTech in Power System and his MTech in Power System and
Power
and his
system
MTech
engineering.
in Power Systems in 2024 from Uttarakhand Technical University. He carries more than 13 years of experience in diversified experience in the field of renewable energy, including hydropower, solar power, biogas, plant transmission lines, substations, industrial automation, project management, design, and execution. Currently, he is associated with Skinder Electrical as regional manager in Dehradun, Uttarakhand, and Skinder Electric founded was founded in France in 2000 in 1836. It is a global leader in energy management and automation. The company develops connected hardware, software, and AI-powered systems to make home buildings, data centers, and power grids more efficient and sustainable and digitally advanced. And it is operating in more than 100 countries with over 15 lakh employees worldwide. So it continues to deliver innovative and sustainable energy solutions across industries. So I would like to hand over the mic to Mr. Sandeep Negi sir to welcome the guest of the day.
थैंक यू वैष्णवी जी. अब मैं सबसे पहले तो गुड इवनिंग टू ऑल ऑफ यू. आज की इस सीरीज में बड़ी खुशी की बात है कि आज हमारे साथ रजत थपलियाल जी जुड़े हुए हैं एज ए एलुमनाई. और जैसा कि ट्रेंड है इस सीरीज का कि हम अपने एलुमनाइज को इस सीरीज में एक दिन जोड़ते ही जोड़ते हैं. तो इससे पहले आप लोगों ने देखा होगा MSNE से हमारे साथ स्टूडेंट जुड़े थे. उससे पहले भी हमारे साथ स्टूडेंट जुड़े थे. तो आज रजत खपलियाल जी का नंबर है. तो आज रजत खपलियाल जी से हम चाहेंगे कि वो अपना इंडस्ट्री एक्सपीरियंस हमारे साथ साझा करें. और उससे फ़ायदा ये होगा कि इंस्टीट्यूट के जो जूनियर स्टूडेंट्स हैं वो प्रेरित होंगे और उनको एक प्रकार का मार्गदर्शन मिलेगा इंडस्ट्री के बारे में. तो मैं रजत खपलियाल जी की नॉलेज के लिए ये कहना चाहूँगा कि इस सीरीज का उद्देश्य जो है टेक्निकल इंटरेस्ट रखने वाले प्रदेश भर के स्टूडेंट्स को एक मंच प्रदान करना है. अब मैं ज़्यादा टाइम नहीं लूँगा और आई विल हैंड ओवर माइक टू द रजत खपलियाल जी. प्लीज रजत. Welcome, Rajat.
Yes, good evening, sir.
Good evening.
Good evening to all of you. Myself, Rajat Thaplial, and first of all, thanks to Mr. Sandeep sir and all my seniors, and also thanks to all of you to giving me this opportunity to interact with you. Now, the today's session is for the technical basis. So, first of all, I introduce myself. I am Rajat Thaplial and belong to Dehradun, Uttarakhand. And I did my MTech power system in 2024. Okay, and I have total experience of industries around 13 years, and I have a vast experience of mainly in renewable energy sector as well as different types of project management and like transmission line or government as well as non-government projects. Now today I'm very happy to when I was talk with Mr. Sandeep sir these type of session are now going on, and as I am an alumni, so thanks the opportunity to interact with all of us. So nowadays the situation is very different and very easy if I compare to my BTech time in 2009. At that time the data around the 1 GB for the 1 month. Now the 1 GB data is using only 1 hours. Okay, so you guys are very like very privileged with these opportunities. If anyone, any student can go with the any software or any website, YouTube's, micro copilot, chat GPT. These type things are nowadays are present. But only thing is you have a courage about the technical knowledge. So I am from electrical field, and the electrical field, as we all know, that there is the green field. And at the time of MTech, Mr. Sandeep sir, Verma sir, and all my seniors sir, Saket sir, all are very supportive, and we are really enjoying that time in YouTube. So right now I am in Schneider Electric company, and I was started from the 2013, and in that time I'm in hydropower project based company. So I will work with different location like Nepal, Arunachal Pradesh, or means I am always try to connect the theoretical practical with practical. So when I was reading like in college time how synchronization was done or generator was done or circuit was working, at that time theoretical experience is different. But when we are going to the field, at that time the theoretical is only formula are used, or but mainly the practical thing are very different situation. How synchronization done, different type of generators are run with the sound effect. Okay, so I am experienced in like a production of panels, control panel, ST panel, 33 kV voltage, 132 kV voltage, control relay panels, generator, transformers, like in hydro. After that, I switched to a solar power sector. So I have an experience of around more than 300 megawatt solar power projects in renewable energy sector. The solar is a nowadays very need in so like a renewable energy, as we know all that. So like biogas, how to gobar gas to convert into electricity, or solar energy, sun to electricity, or wind energy. These type of renewable energy are nowadays very useful to us. So you are from the any branch like a EC or electrical or like a VLSI branch. You guys, if you are interested or work with like that projects or that company, so the opportunities are very vast, because nowadays Modi ji or every government also focus on the renewable energy focus. Okay, so right now I'm in Schneider Electric company, that is a France based company, and founded in 1836. So but that company is working in India from 1963. So in our company, more than 1.5 lakh employee and 100 plus countries all over the world. So I am working in Dehradun, Uttarakhand mainly. I'm a regional head, and I am taking care of all the projects of like a new project, greenfield project or brownfield projects. Greenfield projects are like those projects are very started from the ground level, like a fresh land or that type. A brownfield project we are called like a pre-planned or like a past factories. Okay. So our company are working in mainly electrical field, software field, data analytic field. We are offering a grid to plug solution. But now today, as Sandeep sir told me, the time was very short, so I am giving or show you some minor slide, not a giving, because if I talk to the company, I think one day is sufficient for me, because our company is very innovative company and working mainly in energy sector.
वो
Okay.
डिटेल के लिए रजत रजत वो डिटेल्स के लिए आपको जो है ना 1 घंटे का सेशन हमको देना पड़ेगा आपको, है ना।
बिल्कुल सर,
और
बिल्कुल।
क्योंकि हम चाहते हैं कि एलुमनाई जो है इतने बड़े एरिया में और इस तरीके से काम कर रहे हैं, तो वो एक्सपीरियंस जो है शेयर करें अपने जूनियर्स के साथ में, है ना। तो
बिल्कुल सर,
एज ए
बिल्कुल।
एलुमनाई हमने इनवाइट किया। अभी तो बच्चों के प्रेजेंटेशन होंगे, है ना।
जी, जी।
लेकिन पूरा डिटेल सेशन भी आपका होना है, मतलब ठीक है, तो उसके लिए भी
ओके
टाइम
सर।
देंगे आप, है ना, उसके लिए भी इनवाइट करूंगा मैं जी।
ओके सर,
आप
ओके
बात
सर,
करें।
2
हाँ
मिनट्स।
हाँ हाँ,
सो
करिए, कंटिन्यू कंटिन्यू जी।
yes, so our company is mainly define a grid to plug solution. We are working with a live from a socket to the 132 kV substation. So you guys, if known the name of like a Pitbull, UJVNL, UPCL, we are supplied all there, like a transformer, RMUs, or different type solution. That's why we called our grid to plug solution. From switch socket means from your home switch socket to grid 132 kV substation. Schneider is the only company that working on this type of projects. Okay. So the mainly concept of our company is how to connect with AI based company or AI based solutions to sort the time or to control the equipment systems. Okay. Global energy leadership. Schneider Electric leads globally in energy management and automation, focusing on sustainable and digital transformation is the main focus of Schneider Electric. Okay, we are integrated, completed to the all the grid solution to a one location and working in different sector like a EV or solar substations. As I told, we are working in different type of substation like a Pitbull or that type. These are the slide we are showing. Okay, now this is the company, our root in India started from 1963, Schneider Electric, and nowadays at 2020 we are take over the L&T company. As I know, you are, I think आपने सुना ही होगा सबने नाम L&T का. So nowadays we are change the name of L&T like a L&K Lawrence Knudsen, and that is the company our part. Okay, we are take over this company. So this is the our complete history of Schneider Electric. Like we how we start from 1963 and then 1995 2020. APC is our Luminous is also our brand. Okay. L&T is our brand. Most are the Conserve are our brand, and more than 60 years in India and very a good presence like a grid solution or complete solution everywhere. We are connected like this in project digital powertrain. We are how connected like from our grid tower to MV panel, transformer, ring main unit. आप लोग जो अभी पढ़ रहे हैं आई थिंक उसमें कुछ अभी स्टूडेंट्स समझ भी पा रहे होंगे और कुछ नए सुन भी रहे होंगे नाम, लेकिन इनको आप अगर अभी बीटेक में या वैसे आगे एमटेक के कुछ स्टूडेंट होंगे देखेंगे तो ये सब नाम ऐसा नहीं है कि कुछ अननोन है। बस आपको कोरिलेट करना है कि अगर आपने पढ़ा है एसीबी तो एसीबी में आपने काफ़ी टाइप पढ़े होंगे, तो अब रियल में एसीबी आएगा तो आप पहचान भी नहीं पाओगे। इसलिए मैंने आपको जो शुरू में कहा वो होता है हर स्टूडेंट के साथ ही, हमारे साथ भी हुआ है कि मतलब फील्ड में जाके चीज़ जो होती है बिल्कुल डिफरेंट हो जाती है। तो उसका मेन जो फोकस है वो यही है कि आप चैट जीपीटी और इन सब का यूज़ करके नाउ डेज का मतलब जो भी है उसको यूज़फुल करो मेनली कि कैसे कनेक्ट कर रहा है। आप सिर्फ मतलब स्टूडेंट या कोई भी चीज़, मेरा कहना यही है कि सिर्फ इसमें फोकस ना करें कि एक मतलब हमने थ्योरी आई है वीसीबी क्या होती है, SF6 क्या है और ये सब चीज़ें क्या हैं, और एक नंबर लाने की एक जो बोल सकते हैं कि सब में होती है हम मतलब कॉलेज टाइम पे, लेकिन कहीं ना कहीं कुछ चीज़ रहती है। ये एक प्रोजेक्ट किया है मैंने, आपको दिखा रहा हूँ शॉर्ट में। ये पूरा मोर देन 30 मेगावाट का प्रोजेक्ट है हिली टेरेन में। ये पूरा सोलर का रिन्यूएबल एनर्जी, ये भी मैंने ही पूरा डिजाइन एंड एग्जीक्यूट किया है। उत्तराखंड में ही है ये प्रोजेक्ट। कभी डिटेल में बताऊंगा आपको बाकी कहाँ पर था कैसे था, या किसी स्टूडेंट का कोई क्वेश्चन हो तो काइंडली पिंग मी और डायरेक्ट कॉल मी। ओके, सो दीज आर द स्लाइड एंड so the time is very short. So at last I am last but not the least, but मैं यही कहना चाहूँगा आप सब लोगों को, स्टूडेंट को। अभी स्टूडेंट आई थिंक अराउंड 7 to 10 पीपल्स मुझे दिख रहे हैं। तो यही कहना चाहूँगा कि आज की डेट पे कंपटीशन भी काफ़ी है और कंपटीशन नहीं भी है। काफ़ी इसलिए है कि पॉपुलेशन इतनी ज़्यादा हो चुकी है कि हर किसी को जॉब चाहिए, लेकिन देखा जाए तो मतलब बहुत कम स्टूडेंट हो जो रियल में ही टेक्निकल साउंड बनना चाहते हैं या काम करना चाहते हैं, हर किसी को मतलब जैसे आप भी सुनते होंगे काफ़ी सभी बीटेक कर रहे हैं, लेकिन हम उस टाइम भी वही थे। मैं आई एम ऑल्सो अ सेकंड टॉपर ऑफ बीटेक एट यूटीयू। माय कॉलेज वाज शिवालिक कॉलेज ऑफ इंजीनियरिंग 2013। तो मेरी तब भी कोशिश वही थी, आज भी वही थी कि जो भी हम फील्ड में देखते हैं उसको आके हम लर्न आउट भी करते हैं कि कैसा ये काम कर रहा है, कैसे अभी की जैसा आप ने SF6 वगैरह ब्रेकर वगैरह VCB वगैरह पढ़ा होगा। तो आज की डेट में क्या आ गया है कि SF6 को भी रिप्लेस कर दिया हमने AIS से, क्योंकि SF6 इज वेरी डेंजरस। कार्बन एमिशन बहुत ज़्यादा होता है इसका, अगर कोई टैंक से लीकेज या कुछ भी हो गया तो बहुत ही ज़्यादा, मतलब अभी लगा लीजिए कि जितना मोर देन 26 ट्रीज जो ऑक्सीजन देते हैं उससे ज़्यादा हार्मफुल गैस होती है एक वैक्यूम सर्किट ब्रेकर के अंदर टोटल। तो ये सब टेक्नोलॉजीज है जिसमें आपको काम करना है, पढ़ना है। और सर जैसे बहुत अच्छा गाइडेंस में है संदीप सर और वर्मा सर, जितने भी साकेत सर वगैरह हैं, जब भी इनसे मतलब देखो बिजी तो सभी रहते हैं, लेकिन आप लोग इनके टच में रहोगे तो ही इज़ वेरी मोर एक्सपीरियंस पर्सन। तो आपको कहीं ना कहीं सॉल्यूशन मिलेगा प्रोजेक्ट्स में और सब चीज़ों में। तो मैं एट लास्ट यही कहना चाहूँगा कि फील्ड बहुत बड़ी है और सीखने के लिए भी बहुत कुछ है, तो आप लोग इसका लुफ्त उठाएं अभी एज ए स्टूडेंट। बाकी थैंक यू। एनी क्वेश्चन एनी स्टूडेंट फ्रॉम साइड?
किसी स्टूडेंट का कोई क्वेश्चन है तो थपलियाल जी से पूछ सकता है। और कुछ जो स्लाइड की बात कर रहे थे आप, तो आप हमें शेयर कर दीजिए। स्टूडेंट्स को मैं ग्रुप पर उनको भेज दूंगा, है ना।
ठीक है सर, ठीक है।
बहुत अच्छा लगा थपलियाल जी।
थैंक यू सो मच
और
सर।
आपने ज्वाइन किया। और
जी जी
डिटेल सेशंस भी हम चाहेंगे कि इसी ग्रुप पर, इसी सीरीज में, है ना,
जी सर।
कभी 1 घंटे का ड्यूरेशन का आपका पूरा रखेंगे। तो उसमें जो
बिल्कुल
है
सर।
आप अपनी स्क्रीन शेयर करके और जो डिटेल्ड कंपनी के हैं, किस तरीके से आप जो चैलेंजेस हैं वो फेस करते हैं इंडस्ट्री के अंदर, और क्या शुरुआती स्टेप्स होते हैं, क्या अनुभव आपको होना चाहिए है, और कैसे कैसे करके आप हायर टू हायर पोजिशन पर पहुंचता है। तो मैं डिटेल के लिए आपको बाद में कॉल करूंगा। तो फिलहाल के लिए बहुत बहुत धन्यवाद रजत पटियाल जी। मैं
जी सर, थैंक यू।
हैंड ओवर करता हूँ वैष्णवी जी को। देन वैष्णवी प्लीज।
So, thank you so much, Mr. Rajat Thapliyal, sir, for your valuable and inspiring words. Your guidance and experience truly motivate us to move forward with greater vision and confidence. Now, with your permission, sir, may we proceed further with today's presentations?
यस 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 यू कैन।
So, the first presentation of the day will be delivered by Ms. Vipra ma'am from Power System Engineering. She is currently pursuing her MTech from the Faculty of Technology, and her topic for today's presentation is fuzzy logic and neural networks. So, without any further delay, I would like to invite Ms. Vipra ma'am to take over the stage.
Good evening, everyone. Am I audible?
Yes, ma'am.
Okay, I'm MTech Power System in UTU. Start. Precision and uncertainty.
विप्रा, आपकी आवाज आ नहीं पा रही है थोड़ा सा।
From the
थोड़ा थोड़ा फैन
but
से दूर हटेंगे
in
आप?
outside of the room for a second and care about zeros or ones. Of gray areas. So today we are going to
I'm actually, the voice is not clear.
a brilliant mathematician and computer logic and realized it was fuzzy logic. The manner, like if I say subjective. So the absolute true or false
I think voice is not properly audible.
have to
Vipra?
jump from 0 to 1.
Vipra ma'am, excuse me, voice is not audible properly.
I'm taking a simple example because it talks in the terms of so if the room is 24.9 degrees Celsius, just above 25, how the room feels, you might machine the exact mathematical language, the values of which can be warm and one, which can, in real life, real world. Yeah. Real world and they also report errors.
हाँ
Like
विक्रा, आप मुझे सुन पा रहे हो? आपकी आवाज सही नहीं आ रही है। हेलो,
make the balance. So we can't really.
Sir, it might be like internet issue.
हाँ maybe.
Also communicate language. Humans actually communicated.
इनका फजी लॉजिक पे बहुत बढ़िया प्रेजेंटेशन
Stupid, normal daily life. What? Instead of numbers every single day, हम वही पैटर्न जैसे हम एक दूसरे से बात करनी पड़े मशीन से बात करने के लिए. This journey. Suppose like a stand introduce Alexa, controlling light. हाँ जी सर। ठीक है सर, ठीक।
सर अभी आ रही है?
हाँ, अभी आ रही है।
हाँ अभी आ रही है। ओके सर, शुड आई कंटिन्यू फ्रॉम द बिगिनिंग और फ्रॉम दिस स्लाइड?
स्टार्ट से हो सकता है,
स्टार्ट
अब
से
तक
हो
मुझे
सकता
लगता है।
है, अब तक मुझे लगता है। So I am again starting with differentiating between classical logic and fuzzy logic. Classical logics are which can be represented as step function, which only talks about zeros and ones, which represent true or either false. You are either completely inside a category or completely outside it. It is very exact and it is very sharp. It has definite boundaries. But on the other hand, fuzzy logic, it has gradual transition, often shaped like a curve or a wave. It is the range between zeros and ones. Fuzzy logic also allows you to be like somewhat tall in between the range. You might have 70% membership in the tall category and 30% membership in average height category. So fuzzy logic really give a range between zeros and ones. How this range is given, we will discuss it in next slide. Um, so let's talk about fuzzy sets. This brings us the core building block of the technology. In traditional set theory, an item is either a member of a group or it is not. If you have if you have a set of hot temperatures, suppose 30 degrees Celsius, so 30 degrees Celsius is either in it or out of it. But अगर हम फजी सेट के बारे में बात करें तो फजी सेट इट गिव्स अ डिग्री ऑफ मेंबरशिप रेंजिंग फ्रॉम 0 to 1. In this range, there is absolute golden rule. The key point you must remember is an input can belong to multiple fuzzy sets simultaneously. A particular input which is 30 degrees Celsius, uh, it is defined in three outputs, which is called warm and hot, which has 0. 0.2 degree of membership in the cold range, 0.7 degree of membership in warm range, and 0.4 degree of membership in hot range. It holds all three truths at the same time. It doesn't only have a single output, single answer for single input. And how these degree of membership is defined, it is defined by the help of membership functions. These membership functions are graphical representation of the output which we have given, which the membership function defines the fuzziness in the set, the range between 0 to 1, and it is represented in graphical form. The different shapes which we can use is triangular, trapezoidal, Gaussian, and sigmoid. These are the graphs which are represented: triangular, Gaussian, trapezoidal, and sigmoidal. Triangulars, which we can use for super fast computation; trapezoidal for this particular range of trapezoidal function can give 100% truth across a different range of numbers. And sigmoidal function has an open-ended curve, so it can be used for modeling natural and organic variations. How these intelligent fuzzy logic controllers work: so this is the flowchart for fuzzy control. First, we take the input with the help of sensors, we fuzzify it, we use inference, then we defuzzify it, and we actuate the signal. We will talk about this in the next slide. So, fuzzification we will start with. Fuzzification basically is fuzzification takes a crisp raw data from the input and converts take fuzzification is the process in which the input is taken as raw numerical data input from a sensor, like an exact reading of 32 degrees Celsius, and feeding it into our membership functions to figure out how our fuzzy degrees of truth. The process flow is really simple. The system receives the exact raw input, it compares the number against our predefined membership shapes. A particular membership function will be assigned to that input. It calculates the exact intersections for the input. As you can see in the example of in this slide, an input of 32 degrees Celsius might say that the temperature is warm with a strength of 0.6 degree of membership, and hot with a strength of 0.4 degree of membership. So why is this so vital? It is because of, without fuzzification, our modern smart devices would behave like old machines which were incredibly rigid. There were no uncertainty and flexibility in the machines for outputs. Like for a person who has lesser or no knowledge of uh, science or mathematical terminologies, it would be difficult for that person. Fuzzification solves that process. And how that process is solved: it is with the help of linguistic variables. The linguistic variables are human like language. It is it is human, like we talk in very simple language. In the very beginning of this presentation, I talked about
विप्रा
talking to the machine.
विप्रा सॉरी, आप हिंदी में ही बोल सकते हैं अगर अच्छे से आपको लग रहा है तो। ऐसा कोई इशू नहीं है।
ओके सर, ओके ओके। तो ये लिंग्विस्टिक वेरिएबल्स एक ह्यूमन लैंग्वेज लेयर है. These are variables whose actual values are real words or phrases from human speech. The input is taken as cold, warm, hot, or very hot. Such type of language is taken as variables for the machines. Instead of AI dealing with purely with an abstract array of numbers like 12, 45 or something like that, the system processes concepts like cold, warm or hot for temperature, and also slow, medium, fast for speed, or low, medium, high or critical for risks. This uh, this linguistic variable gives us massive advantages. It means system rules can written be in plain straightforward English, like the linguistic function where we can literally talk to the device with our native language, or you can say English, to give the machine instructions or desired outputs for any particular input. So how fuzzy rules work? It works on the logic of if and then. If temperature is hot, then fan speed is high. If speed is fast and road is wet, then braking force is strong. If pressure is low or high or flow is high, then valve is open. These are such examples of fuzzy rules. This this is where we write the actual rules of operation, and they look exactly like how a human expert thinks. And here there is no multi-layered calculus equations. There is very simple language, which is these simple words: hot, high, fast, wet, strong. These simple linguistic variables we are using to communicate with the machine. So how this inference engine works: if a rule uses an and operation, the engine is conservative. It looks for the minimum membership value. If a rule uses an or operation, it looks for the maximum value. It aggregates all the outputs from the every single rule that fired, combining their shapes together into one final irregular fuzzy output shape. For example, look at this slide. If our rule says if temperature is hot and humidity is high, then cooling is very high. If our hot membership is 1 but our humidity membership is 0.9, then the engine takes the minimum, which is 0.9. That becomes the strength of our final action. This is the final practical, the roadblock, defuzzification. Machine cannot execute a fuzzy shape. It it needs to the logic to be defuzzified for to give it the instruction, particular instruction. An automatic braking system cannot brake somewhat hard. A hydraulic pump cannot apply little bit of pressure like in human language. It can't work. So it needs an exact number. So we defuzzify the logic. A machine needs an exact number. This leads to our final step, defuzzification. This is where we convert our complex fuzzy conclusions back into a single crisp number. This diagram, the system might have evaluated rules for like a fan speed rules. So as you can see in the diagram, the system might have evaluated rules for low fan speed, medium fan speed, and high fan speed. Defuzzification blends those results together, find the exact mathematical balance point, the center of gravity, and outputs a precise real world command like set fan speed to exactly 72%. This is the use of fuzzy logic in intelligent control system, which can help in industrial robotics, smart traffic functions, traffic systems. Smart traffic systems is like the fuzzy logic can interpret the congestion levels on the road and optimize the traffic signals according to that. Cement kiln control and smart home systems. These are the real world applications of fuzzy logic. Washing machines, we can use it according to the load and the dirt level of the clothes. Camera autofocus, air conditioning, Like we keep changing the temperature and we keep switching off if the room becomes really cool, then we keep switching on and off the AC. So fuzzy logic can help in air conditioning also, stock predictions, medical diagnosis, and smart traffic control, as I mentioned. These are the advantages and limitations of fuzzy logic control based control systems. It has human like reasoning, as I talked about it, like it talks in human language, flexible and robust to noise, handles uncertainty effectively, simple implementation for complex problems. It has no exact mathematical model required. It is easy to modify and extend with new rules because AI is introduced in fuzzy logic, and AI combined is easy to modify because AI changes it with time. It upgrades itself. What are the limitations for it? These, like I talked about, membership functions are really subjective, like the category of tall, category of short, warm, hot. From person to person, these function can be really subjective, so it can be a really drawback for fuzzy logic system. The fuzzy logic plus AI gives us hybrid intelligence, which can also be called neuro fuzzy systems. Engineers are now combining the learning power of neural networks with transparent reasoning of fuzzy logic to create hybrid intelligence. Also, by integrating fuzzy logic, we create explainable AI, which is also known as XAI. The system can explain its decision to human operators using clear and human readable if then rules. It gives us the best of both worlds. This is the future scope of fuzzy logic. IoT, billions of cheap edge sensors are generating massive amounts of noisy, imprecise data, and fuzzy logic will be essential for intelligent edge processing directly on those small chips. And this industry 4.0, cyber physical manufacturing requires highly robust adaptive control for the robots which are working in industries, like precise hand control, hand movement and leg movement. This can be controlled through fuzzy logic. And in autonomous systems, which are self-driving vehicles and drones, for immediate, like for emergency braking or immediate braking systems, fuzzy logic can be really meaningful for that. Also in smart cities, our entire infrastructure from energy grids to emergency services will be benefited from distributed fuzzy logics and control networks. So to wrap up things up, Lotfi Zadeh once beautifully stated that fuzzy logic bridges the gap between human reasoning and machine intelligence. It extends rigid binary logic so machines can handle real world uncertainty. It enables human like reasoning in cold and impreciseness, and it remains an absolutely foundational pillar for the future of intelligent control, automation, and AI. Thank you all so much for your time and attention today. I would love to open up if any questions are there. Thank you.
Thank you so much,
Thank you so much,
Mitra ma'am,
Mitra ma'am,
for such an
for such
insightful
an
and
insightful and
wonderful
wonderful
presentation.
presentation.
Now, if
Now,
anyone
if
from the
anyone from the
audience has any
audience has
questions,
any questions,
feedback, or
feedback or
suggestions, you are most
suggestions, you are
welcome
most
to direct.
welcome to direct.
आपकी
आपकी
साउंड
साउंड
कुछ रिपीट हो रही है.
रिपीट हो रही है.
हेलो.
हेलो.
Yes, sir.
Yes, sir.
हाँ जी
हाँ जी,
मैम, अगर आप
अगर
सिंपल
आप
भाषा
सिंपल
में
भाषा
बताना
में बताना
चाहेंगे
चाहेंगे
कि फिजियोलॉजिक है क्या,
फिजियोलॉजिक है
तो
क्या,
आप
तो
क्या
आप
बताएंगे
क्या
दर्शक
बताएंगे
किसी को पता नहीं
किसी
है.
को पता नहीं है.
सिंपल इन 3
सिंपल
वर्ड
इन
और 4
3 वर्ड
वर्ड
और
में.
4 वर्ड में.
सर फजी लॉजिक जैसे अभी तक कंप्यूटर सिस्टम्स जिस पे हम वर्क कर रहे हैं, वो सब जितनी भी हमारी प्रोग्रामिंग है और जो भी हम इनपुट्स देते हैं इसमें कंप्यूटर्स में, वो ज़ीरो और वंस के टर्म्स में होता है। इवन द लैंग्वेज वी राइट लाइक अल्फ़ाबेट्स भी ज़ीरो और वन के टर्म्स में कोडेड होते हैं।
ठीक है।
तो उसी को रिप्लेस करते करते हमने मल्टीपल लैंग्वेजेस इंट्रोड्यूस करी है, जावा आई, सी प्लस प्लस, फिर पाइथन। उसको हम और आसान करते जा रहे हैं, और जैसे पाइथन की लाइब्रेरी बहुत वास्ट हो चुकी है, हमें डायरेक्टली हम एक पर्टिकुलर कीवर्ड यूज़ कर लेंगे कोई भी इंस्ट्रक्शन देने के लिए। तो सर ऐसे ही फजी लॉजिक इंट्रोड्यूस हुआ है, जहाँ पे हम एक जैसे इनपुट, जैसे हमारे फैंस और बल्ब जो लाइट स्विचेस होते हैं वो या तो ऑन होते हैं या फिर ऑफ होते हैं। तो फजी लॉजिक उसमें एक वेरिएशन दे देता है बीच में, 0 से 1 के बीच का वेरिएशन। हम फ़ैन की स्पीड को, पहले रेगुलेटर क्या होता था, 1 to 5 तक नंबर होते थे, हम रेगुलेटर को घुमा सकते थे 1 2 3 4 5 और फ़ैन की स्पीड डिसाइड कर सकते थे। अब के टाइम पे टेक्नोलॉजी फजी लॉजिक जब इंट्रोड्यूस हुआ है, हम फ़ैन की स्पीड को 0 से लेकर 1 में किसी भी रेंज में उसकी स्पीड को सेट कर सकते हैं। ऐसे ही बल्ब की इंटेंसिटी को, और यही यही एग्जांपल्स एसी सिस्टम्स में और जितने भी हमारे होम इक्विपमेंट्स और इंडस्ट्रियल रोबोट्स हैं, इनमें सब में इंट्रोड्यूस कर रहे हैं। बीच की जो रेंज है ये 0 से 1 की रेंज।
ठीक है। ओके।
सर
ओके वैष्णवी जी, आगे भेज दीजिए किसी और को।
Okay. Thank you, Vikram.
थैंक
Now,
यू सर।
So thank you everyone. Now let us move ahead with the second presentation of the day. Our next presenter is Mr. Piyush Naithani sir from Birla Institute of Applied Sciences and from Bhimtal district, Nainital. His presentation topic is energy forecasting and research domain. So please welcome Mr. Piyush Naithani sir with a round of applause.
और मैडम हो सके तो ना एक मतलब 30 सेकेंड या 1 मिनट के लिए कोई अपना फेस भी दिखा दे तो ज़्यादा अच्छा है। क्यों संदीप सर, मतलब मेरा कहना क्या, थोड़ा सा इंटरेक्टिव बन जाता है सेशन, है ना।
Yes, sir, for sure.
स्टूडेंट्स को आप गाइड कर सकते हैं।
अगली बार से करते हैं। ठीक है।
Good evening, sir. Am I audible? Hello.
जी जी,
Yes,
audible।
yes.
Okay, sir. 1 minute. So I'm gonna start. So I'm gonna start my presentation. So good evening, everyone. Myself Piyush Nathani, and I am from Birla Institute of Applied Science, Bhimtal, and I am currently a third year student in CSE branch, BTech. And so for my today's topic for the presentation is energy forecasting and research domain. So the problem statement from this AI knowledge and network system, which is how can artificial intelligence improve energy forecasting to manage the increasing energy demand, reduce energy wastage, and support sustainable energy systems in rapidly developing countries like India. I am referencing India. So, as we all know, that the global energy demand is increasingly rapidly. So, traditional systems cannot accurately predict energy usage, which leads to the power shortages, high electricity costs, fuel price instability, and a few more. So, what are the needs for the energy forecasting? Why do we need it? We need it because then we can have better energy management, efficient use of renewable energy, and reduce dependence on imported fuel. So Let's talk about some geopolitical situations and future scope also, because why is it energy forecasting is very important for nowadays world. As we all know that the recent global issues like the Russia-Ukraine war affected global supply, oil supply. Middle East tensions also increase of fuel prices worldwide. And what are the impacts on India? The impacts include the rising petrol and electricity cost, growing energy demand, and import dependence. What are the future scope for this system? Are first is that we can have an AI-based smart energy system and solar and wind energy forecasting, and sustainable and efficient energy management. So it's not that I have just created a PPT for this. I have also given a solution. This is one of the project that we have been that I with a few of my friends have been working on. So this is the project Sunrise, which is an AI powered sensor-less tracker with smart weather protection. So, Sunrise is a low cost intelligent solar tracking system that improves energy efficiency and protects solar panels from extreme weather. Instead of using fragile light sensors, Solar Sense relies on mathematical solar models, real time weather data because we are using an API from Open Weather API and Gemini assisted automation to make smart decisions, all built using recycled materials. So what is the inspiration of this idea? From where we get this inspiration that we have to create this sensor-less solar tracker? The idea for this solar sense for this sunrise came from observing how most small scale solar panels work in real life. They are usually fixed in one direction, which causes two major problems. I repeat, which causes two major problems. First one is that they lose a lot of energy efficiency as the sun moves across the sky. Secondly, during the bad weather, especially hailstorms, these panels are easily damaged, reducing their lifespan and increasing maintenance cost. So, what are the problems that we are solving over here? So the background of this problem is that most conventional solar panels operate at a fixed tilt angle, limiting energy harvesting, which we need because for weather forecasting we need to have maximum energy. Sensor-based tracker system. There are sensor-based tracker systems, but which with improved efficiency, but they increase the cost, hardware complexity, and maintenance requirement and lag in safety features. The motivation is same to eliminate the dependence on physical light sensors through algorithm-based solar position estimation, and the third, and to achieve higher energy yield with reduced hardware complexity and lower operational cost. Research gap. What is the research gap in this? Limited development of affordable sensor-less tracking system with intelligent automation, lack of integrated solutions combining algorithmic tracking, smart safety protocols, and IoT-based monitoring. So this project has mainly three brains. First one is this random forest algorithm, which is the main decision maker. So you can think of it like many small decisions tree voting together. For example, the system checks the temperature, the time, the cloud coverage, the sunlight intensity, the previous power outage output, and the season. Then maybe the random forest predict that they rotate the panel 23-degree east. So and why we use it? Because it is much better than the Gemini for real-time control because it's fast, accurate, lightweight, works offline, easy to train. Perfect for Raspberry Pi. We have used it. Second one is Olama models. It lets you run open source AI models locally. So, for example, we have an app for this. There is an app for this project, and uh, the user can ask from the chatbot why did the panel stop moving. So the orama or the chat will reply the cloud density increased and power gain from movement was very low, so the system minimized water usage. So this will gives a very good impression to the user. Third one is fine-tuned sonar dataset, which fine tuning means teaching the AI specifically about this solar tracking data. So uh, after the training, the model becomes specialized for locals or solar systems. So together they make a small automation for autonomous solar tracker. Now this is the project image that we have. So as you can see that there are two images. This you can see is we have created it on a breadboard, but we are on a final stages of creating it on a motherboard with all the wiring and everything done. So it's not gonna look so much messy. And this is the main device. So this is, you can see that there are two servo motors and one small battery which is gonna be powered by this solar panels. And so it's not just that we are just doing a project and not doing anything. We have also published a research paper for this. And so I would like to thank very much for college teachers like Neeraj Bish sir and Miss Shilpi Bish ma'am, uh, and my college, my dear friends like Mohammad Anas and Niranjan Kanpal. So how we build it and how is gonna help us increase the energy which we are getting. So in this, first we have used the Android app built using Java and EMI. Second one is we have used the ESP32 controller for communication and control. Third one is Wi-Fi communication using HTTP request. And fourth one is servo motor for panel movement. And this is very important that the EEPROM for saving last on state for power recovery. For example, if something some error occurs, so the panel can move to its last position. And it's built using low cost and recycled components. So, what are the accomplishments of this? First one is we developed a sensor and a solar tracking device, which is very good for because we can increase the energy output of any solar panel around all over India. And as we all know that there was a news in Indian media that the government of India has instructed the people to use more energy during the peak 11 to 12 p.m. 11 to 12 p.m. because a lot of solar power is being generated, but a lot of that is being wasted because it's so much energy. And second one is implemented automatic hailstorm protection because uh, as soon as hailstorm occurs or we from the weather API, open weather API, we are getting the data that the hailstorm is about to occur. The panel will automatically moves at a perpendicular angle, so the hailstorm is gonna hit not gonna hit the solar panel itself, but the side of the panel which we are gonna be refurbished, and we are gonna place rubber tires and use rubber layer over it, so hailstorm is not going to damage it. And clean UI with manual and auto modes significantly reduce cost using recycled materials. This is very important because our main goal was to just increase the energy output and make it scalable for the real world and education use. And thank you. Sir, it's over. I can also show a small working of this project, but if you can allow me,
हाँ
or
हाँ
so.
yes, 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 yes. If
Okay,
there is
sir.
working model, then you can show.
Okay, sir. Uh, is my voice audible throughout? Was my voice audible throughout the presentation? Was
Yeah,
there no?
it
Okay,
was
sir.
nice.
Thank you very much, sir. Yes, sir. So let me just set it up. 1 minute. It's actually on the dev post. So it's actually on the dev post. So I need to make a small adjustment
हाँ
so
कोई
that
बात नहीं,
it's
टाइम
visible.
लीजिए। टाइम
Yes, sir.
लीजिए, वर्किंग मॉडल है तो बहुत अच्छी बात है, बहुत बढ़िया।
Yes,
गुड।
sir. So the working which I have shown you, let me just, sir, I think you must have seen this in the YouTube Utkarsh hackathon, but we have more upgraded that version with more AI models in it, like random forest and like random forest algorithm and everything. And also one more thing that we have used, uh, is gonna be a supervised learning. The AI
अच्छा,
model is gonna be
आप
trained
थे
using
आप
supervised.
थे उस हैकाथन में प्रेजेंट यहाँ पे, जो
हाँ
पिछले साल
सर।
हुआ था?
जी सर, उत्कर्ष वाले में थे हम। तो कुछ प्रॉब्लम हो गई थी, हमारा मॉडल वो चला नहीं, पता नहीं क्यों। सो
ओके,
सॉरी सर, दिस इज द स्मॉल वीडियो व्हिच आई एम गोना प्ले सो यू कैन हैव इट।
यस, प्लीज।
We are
Oh, sorry,
planning
sir. Sorry, sir.
features like real-time
Sorry. Let me just I forgot to open the video.
artificial intelligence so that it always aligned to the science. We have incorporated artificial intelligence so that it can take automatic decisions in bad weather or when needed for panel alignment. What we have built is just the beginning, the potential much bigger. We dream of solar cells being mass deployed in off-grid schools, rural electrification programs, sustainable farms, and even disaster relief operations. We are planning features like real-time energy logging, voice assistant integration, weather-based automation, and solar cleaning modules. With just a little support, this open source, low cost, scalable solution could change how solar is used across Indonesia and beyond.
So, sir, this was our whole idea, and how we can increase the energy efficiency through it. So, thank you, sir.
हाँ, बहुत बहुत ही सुंदर, है ना?
Thank you, sir.
वैष्णवी।
So, thank you so much, Mr. Piyush Nathani, sir, for such an authentic, informative, and engaging presentation. We truly appreciate your efforts and valuable insights.
Thank you, ma'am. Thank you, everyone.
And I would like to thank all the dignitaries who were present here throughout the session for listening and being interactive during the whole session.
हाँ, बहुत-बहुत धन्यवाद। सभी जो रजत थपलियाल जी हमारे साथ जुड़े थे और उसके अलावा विप्रा ने जो अच्छा प्रेजेंटेशन यहाँ पर दिया, उसके लिए भी बहुत-बहुत धन्यवाद। पीयूष नैथानी जी हमारे साथ भीमताल से जुड़े हैं और उनका भी बहुत-बहुत धन्यवाद और इस तरीके से आपने हार्डवेयर मॉडल का वीडियो भी हमको दिखाया, तो बहुत ज़्यादा इंटरैक्टिव ये सेशन उस वजह से हो गया है और बाकी जो स्टूडेंट्स यहाँ पर हमारे साथ जुड़े हुए हैं, तो एक नॉलेजेबल और नॉलेज शेयरिंग का ये प्लेटफ़ॉर्म है। तो आगे भी हम लगातार इसी माध्यम से जुड़े रहेंगे और नॉलेज शेयरिंग का ये बेसिस और ये प्लेटफ़ॉर्म उत्तराखंड के लिए बेनिफिशियल होने वाला है। तो सभी लोगों को एक बार पुनः धन्यवाद और अगली मीटिंग के लिए हम कल 8 बजे फिर से जॉइन करेंगे। थपलियाल जी धन्यवाद।
Okay, thank you so much, sir. Thanks to all.
ओके। और वैष्णवी जो लगातार हमारे साथ सेशन में बनी हुई हैं, उनको भी बहुत-बहुत धन्यवाद। वो लगभग
बिल्कुल।
कल के दिन में उनका प्रेजेंटेशन था, बहुत सुंदर उन्होंने प्रेजेंटेशन दिया और आज मैंने कहा कि आपको एंकरिंग करनी है, तो आज एंकरिंग के लिए भी लगातार उपलब्ध हैं। तो धन्यवाद वैष्णवी।
Yes, sir. Thank you so much for the opportunity.
ओके, थैंक यू।